So we have, yeah, you might have to write on the top, or sometimes they're too small because it's typing that I put the box over top, and you usually write bigger than a person types. So we have learned that relations and functions can be shown as ordered points, as a table of values, as a mapping with one thing to another, as a graph, and as an equation. So what we're looking at today is the graphs. Okay? With the graph, the x values, this is your x-axis, and this is your y-axis, generally. So this becomes always your independent, and this is always your dependent. So if I took a point, right, this point right here is the x is 4 and the y is 12. That would be that point on the graph. On a table of values, we would put time here and depth over here, and we would have, when the time is 4, the depth is 12. So it's really important that we're able to understand these things in multiple forms and translate from one to the other, right? What is this point up here? Well, the time is 16. That always goes first. The y value is 20. The depth is 20. So what is this scuba diver doing? Okay? At time 0, where are they? They're at the surface, right? Because their depth is 0. Then they dive in, and they keep getting deeper and deeper and deeper and just going straight down until they get 12 meters. It takes them 4 minutes to do that. Then what happens at 4 minutes to 8 minutes? They see something cool, they're maybe walking on the ground, they stay at 12 meters deep, and then at 8 minutes, they come to a cavern in the ocean, and they're like, ooh, this looks cool, and they dive down again. So from 8 minutes to 10 minutes, they're like swimming deeper, 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 until they get to 20 meters deep. Maybe they find the ground there in this new cavern. So it's kind of interesting. The graph is going up, but the scuba diver is going down. So we have to be able to interpret this. They check things out between 10 minutes and 16 minutes. Nope, 10 minutes and, oh, I drew this wrong. My eyes were deceiving me. What number should be here? 14. Thank you. So from 10 minutes to 14 minutes, they're checking that out. And then they're like, time to go. And they just swim back to the surface, right? And not super fast, right? It's not like, if it was like super fast, they would need like a jetpack, or maybe there was a shark chasing them, right? Yeah, it'd be kind of, yeah, if a shark got them, this would probably happen. In between there, that wouldn't be very good. So we have to be able to interpret this. And now we can answer questions about it. How many minutes did the dive last? How long were they in the water?
29.
30 minutes. At what times did the divers stop per descent? From 4 to 8 minutes, right? I guess technically they stopped her descent from 10 to 14 minutes as well. How deep did they go? 20 meters. For how many minutes was the diver at that depth? How long were they at 20 meters? Only for 4 minutes. So we have to take a graph and then reenact the situation. The activity that I'll have for you today is I will give you a story, and then you have to think about what the story means and match it to a graph. Okay? So that's what the activity we're doing. We'll do a couple more of these together. Okay? So here's the property of a graph. A lot of times we have time and distance. This is a very typical thing. Okay? Dependence is always on here. Independence is always on here. This is a steep increase, steep decrease. If it's flat, there's no change. A little bit of an increase, steep decrease, slower decrease. Some things to interpret as we're going along. So, example 2. Each point on this graph represents a bag of popcorn. Explain and answer each question below. Which bag is the most expensive? C. So we look at the cost. That bag is the most expensive. Definitely going to be C. How much does it cost? $7. Okay. Which bag has the least mass? Which one's the lightest? B. How much does it weigh? Probably about 500 grams. Which bags have the same mass? Close. D and E. D and E weigh the same. If we go up, they're both 1,800 grams. Which bags cost the same? A and E. How much do they cost? $4 each. Which of the bags, C or D, is a better value for your money? Right? C, you get, if we look at C, you get 1,600 grams for $7, and if you look at D, you get 1,800 grams for $5.50. Obviously, this is an easier one to figure out. And it looks like overall E would be the best value, right? You get the most weight for $4. And if you look at B, which is $2, it's less than half the weight of E. So it looks like E is your best one overall. But between C and D, D is a better value. Jenna likes to do cross-country skiing. Saturday, she skied the Boot Ptarmigan course in 1 hour. The following graph shows her speed along the course and time. So again, you could make a table of values of this. If you made the table of values, time would be first because that's your x or independent value, and speed would be second. I could take point A, and A looks like it's at 5 minutes and 5 kilometers per hour. B, at point B, that's at 10 minutes. How fast does she look like she's going there? You think that's 3 or 4? What would you estimate?
3.
3? Okay. At point C, that looks like at 40 minutes, she's still going 3. And then she stops traveling at 44. her speed is 0. Okay? Or is it it's very, very, is it is slightly more? Do you think it's slightly above? I don't know.
Maybe like 1.
0. Let's do 0.1. Just something a little bit higher. Okay? So let's look at what is her speed at 10:10? That's what we said was 3 kilometers per hour. Important to include the units that are given. Okay? At what time was Jenna's speed at its maximum? At point A. Which is what time? At 10:05. Speed? What is the speed? What did we say it was?
4, I think.
Did we say 4? Or did we write? We wrote 5. It looks like it's just a little bit below 5, but close to 5 kilometers per hour. Describe what happens in terms of her speed between 10:10 and 10:40. Speed, yes. She's traveling at the same speed. Okay? And one of the things that you're going to have to do with these graphs is if they give you a graph of speed, could you make the graph of distance? Okay? Or how much she's traveled, how far she's traveled. Describe what happens in terms of her speed between 10:40 and 10:50. What is she doing? But what is she doing as it's dropping to 0? She is slowing down and stopping. Right? I didn't add a part E. When does the tree fall on Jenna? That would be terrible. You could make. Maybe she just stopped because she was tired, not because a tree fell on her or anything like that. Okay, so I wanted to just do a couple to get you. Oh, they just scored again. Okay, to get you. I'm going to put it on, and while you're working on the assignment, we can watch a little bit. So I'm going to pause the video here.